All right, welcome back to Workplace 30. We're going to continue on with 1.1, Part 3, and we're looking at Example 2 on page 18. We have a events coordinator at a banquet hall. She's arranging a wedding reception for clients. They have not yet decided on the number of guests, so they ask her what price would be for between 50 and 200 people. She creates a graph to show the prices. Is the relation between the number of guests and the cost linear? Yes or no? Is this a linear relation? Yes, it is. Why is it? Yes, it's a straight line. Why else? Because the cost depends on the guest, right? So it's a constant slope or there's a constant relationship. Right on. Okay, so please copy down what I wrote there for part A, and then we're going to look to part B. Does the line pass through the origin, 0, 0? Why or why not? So no, it does not. So what do we call something then that doesn't pass through 0, 0? Good, it is a partial linear relation. And why does it not pass through the origin? Okay, it doesn't start at 0. What does it start at? Good, it starts at about 500. Now, that point where it starts at 500, that's called the y-intercept because that's where it interacts with the y-axis. So our y-intercept equals about 500. So that must mean there's a starting cost of $500 to rent the hall. Doesn't matter how many people you have there. Now, what is the slope of the line? So remember to find slope, we use this formula, m equals y2 minus y1 over x2 minus x1. And before we can do this, we need to pick some points on our graph. So it's easier to see on my slide than on your handout. But if we pick some of these points, this first one here is 50 on the x-axis and 2,000 on the y-axis. You can pick another point here that is 150 on the x-axis and 5,000 on the y-axis. So if this is point number 1 and this is point number 2, we can plug those values into our formula. So our y2 value was 5,000. Our y1 value was 2,000. Our x2 value was 150, and our our x1 value was 50. So 5,000 minus 2,000 is 3,000. 150 minus 50 is 100. Now when we're dividing this, you can actually just cross out the zeros, and you're left with 30. Hopefully you did not type that into your calculator, Mitchell. So then we have 30 is our slope. And what does that stand for? That actually stands for dollars per guest, because the value of the y is in dollars and the value of the x is guests. So dollars per guest is your rise over your run. Okay, third example. We're going to classify each of these graphs with the following criteria. So first, let's look if the graph is linear or nonlinear. So graph 1, is it linear? So yes, it is linear. Graph B, is it linear? No, it is not linear. And graph C, oh, this should have been A. Graph A is also not linear. So then part B, is the dependent variable increasing or decreasing as the independent variable increases? So the bottom, do we have the dependent or the independent on the bottom? Independent, good. So the bottom here is our independent, the side here is our dependent. So for this first one, does it decrease or increase? Decreases, good. So part B we have decrease. How about for the next graph? It's also decreasing. And for graph 3, it increasing except for one part. Where does it not increase? Good, where it goes down, which is there between dots 3, and 4. So increase except between dots 3 and 4. Okay, and part C, do you agree or disagree with the statement? Graph 3 passes through the origin and therefore is a direct linear relation. Justify your response. So is graph 3 a direct linear relation? Okay, so it does pass through 0 and 0, yes. Good, but it doesn't make a straight line. So that means that graph 3, so if I write part C up here, is not a linear relation. So it actually can't. It can't fit into C, even though it does start at the origin. It would need to make a straight line first. Okay, then you have an assignment. This is for homework. Please do numbers 2, 3, 4, and 7 on page 22. Have a good one.